Welcome. In this lecture, which has multiple sessions, we'll explore how to write a multi-layer neural network as a single objective function. The main concepts that we'll go through is we'll have a hidden layer, and that's going to be an array of neurons. The hidden layer can be represented as a product of matrices. Steepest descent is commonly used in neural networks to solve the problem of learning, and this is basically machine learning by using optimization. So the sample problem that we'll look at here is how can we write a steepest descent method for a multi-layer neural network, and we're going to use linear algebra. Let's recall the neuron diagram. Originally we had the data going from the left to the right, which made a certain amount of sense when we thought of data as a vector. Now that we think of data as a one form, we'll write it from the top to the bottom. So our data start and then they go through the weighting, then they go through the summation, and then we get the output. And we'll represent the output as either a function or as a value, depending on our immediate needs. Now we can have one data vector, and we can pump this data vector through a layer of neurons. And so the data flow will be very similar, is that we'll start at the top and go through a hidden layer and go downward. We're going to put leading subscripts, so we'll refer to this as layer number 1 and this as layer number 2, and we could carry on if we needed. So let's now turn to the mathematical representation of this structure.